All right, good morning, everyone. So this is the Schanda Park Living Shoreline Project. It's located right in downtown Newmarket. It's a very urban site, as you can see from this aerial shot. Next slide. Just a quick overview of our project team. Our landowner was Town of Newmarket, and then our design team, the 6 people you see in front of us. I'm Tristan Donovan. Patrick McNally is on the left. Elizabeth Olliver, Bob Uhlig, Deanna Suzor, and Jess on the other end. And then I want to give a big thanks to our project coordinators. We were lucky enough to have 3, Aiden Berry, Linda Cara, and Kirsten Howard.
All right, so I'm going to go over the existing conditions. So starting from the north, we have a large boat ramp. North of that is private property. Most of our area was dealing with stone abutment on the waterfront. We had a collapsing wall right about here. A downward sloping parking lot, Moonlight Brook, and then we had a bluff here, more stone abutment. There was some tidal marsh here, and there was some vegetation in this abutment they were able to find. Some of the site constraints, we had a limited space for the marsh tree due to the hardscapes, like the parking lot, some of the private property surrounding the area. It was a high profile site. It's the only park that the town has. It's used for a wide range of things. Permitting considerations for fill in the river, managing stormwater quality, quantity, and the bank erosion, and accommodations for future work at the Moonlight Brook. The town has done extensive research into kind of fixing that area as well. So we have to take that into consideration.
So when we were beginning our study and trying to develop a site design, obviously the main focus of this project is living shoreline. So we knew that we were going to try and see if that was a viable option for this environment. And one of the first things that we thought about was, well, what is sea level rise going to look like in this site? It's a public park. It's a lot of hardscape, and during king tides and such, it is a highly flooded environment. That being said, it can be flooded. So when we were selecting a sea level rise scenario to consider when designing a park, we sort of chose to go with the intermediate to high scenario. We picked a design time frame of like 30 years, so predicting sea level rise for 2050. And that's, again, because of the hardscape nature of the site and the limited availability of the marsh retreat area. So that gives us a sea level rise predicted of 1.6 feet for the Schanda Park area, which means that we have to think about elevating our tidal marsh at a higher elevation than current day.
As indicated, so we had a variety of different site goals to achieve. The first is to maintain the upland park space much in its current form so that it would continue to be usable by the community, to create a more active waterfront. With that more active waterfront, we had to think about creating a living shoreline, but protecting that living shoreline because there's so much activity within that area. Looking to improve water quality from the parking lot runoff. A lot of runoff coming from the street down towards the river, as well as in the parking lot, and then repair a collapsed stone wall that was located adjacent to Moonlight Brook. So in the overall site plan, we had a variety of different objectives. Again, kind of this is the main road. The road slopes down to the river, and then kind of in order of objectives, because we got a site that crosses a variety of areas here, and existing neighborhood along this edge, roadway, and so forth. So circulation occurs between the parking lot, the public park, the boat ramp, and then this adjacent area that connects to the neighborhood and then down to a floating dock. So a lot of public circulation around. So first, as mentioned, we've got this Moonlight Brook that has a lot of erosive activity that occurs out into the river. We're regrading this area, regrading this area. Along with it, you'll notice the edge of The existing river comes like this, and then it currently comes inward like that. And what we tried to do is extend it out such that it was maintaining the kind of the arc of the river's edge, expanding out living shorelines in both this area and this area. And on this area in particular, we regraded what was an overlook bluff to be a more gradual slope that will allow that living shoreline as sea level rise occurs for it to migrate upland on both sides here. And then also, given pedestrian traffic over to this dock, we're installing kind of a split rail fence along here to help mitigate pedestrian travel across the living shoreline to help make sure that it establishes and isn't affected by foot traffic. In addition, we've got some benches at this location so that you can kind of appreciate it, as well as the idea of having interpretive panels for public education about the living shoreline so that people are aware of its sensitivity and its benefits. On this edge, also expanding the living shoreline and in effect kind of repairing some of the degraded walls that are collapsing here. And Tristan will get into that a little bit more. Also looking to modify the dock right now, as you may have seen in the original images, the boat ramp and dock here extend the whole way from this edge over to this edge. We were looking at the idea of creating a little bit of a living shoreline where it's protected right here, creating kind of a place where personal watercraft could be launched out into the river, and then more minimizing the width of the boat ramp itself, again, to reduce the amount of hardscape. And then finally, this large parking lot area right now is uncurbed. Runoff just runs right across the parking lot and then erodes the edge of the stream here, as well as runs off. And what we've done very simply is look at the idea of introducing a curb to contain this edge, to encourage stormwater runoff to this kind of this catchment area with a sand filter to both reduce runoff and to treat. And with that, I just wanted to highlight also that Tristan is going to be talking about the cross sections that we've evolved. So you'll see there's kind of three cross sections, A, B, and C. And I think we're going to be talking about A.
So these are the cross sections that we came up with as part of our design. This is a little more of the engineering side of it. The top one, it really drives home the point. That's section A. That really drives home the point of we don't have a lot of room to work with. We're in an urban environment. We're restricted on both sides of our section. The bottom edge by the existing toe of the bank, and then at the top edge by the hardscape in the park, as well as the top of our slope. So as you can see, we've only got about 20 feet of low marsh, another 3.7 feet of high marsh, and then our tidal buffer to round it out. The bottom section, we have a little more room to work with, about 50 feet, which we were able to get a little more extensive high marsh and tidal buffer plantings in there. The sill, we're proposing a rock sill along the bottom edge of our sections in order to harden the bottom section. Reusing existing resin on site. Top of that sill was set based on our mean sea level, which was measured by our tidal data that we gathered, plus our 1.6 feet of sea level rise, plus another 6 inches of elevation, just to really help establish the plantings going forward. I mentioned the reuse of the existing stone for the sill, which will be much easier than bringing in rock. We have these choir log grade breaks basically to get partially to get elevation that we wouldn't be able to get on a nice slope, but also partially as a way to prevent the water running down the slope and causing a lot of erosion, and also to separate the high marsh, low marsh, and tidal buffer zones from each other. I mentioned the slope. We're looking at 3% slopes. It's basically enough to drain these areas, but it's not too much that we're not going to get any channelization of the runoff and excessive erosion of the slopes. And then also these marsh locations are sort of kind of in a delta area of Moonlight Brook, where the sediment running out of Moonlight Brook can build up as sea level rise occurs into the future. The sediment coming down Moonlight Brook will hit this delta, the water will slow down and it'll hopefully continue dropping sediment there so that the marshes can elevate with sea level. And then that pretty picture on the bottom left is our section showing all of our plants. It's our pretty standard plants. We got the various Spartinas, Disticus, and then some native New Hampshire upland plants at the top slope. Pass it up. Yeah.
Okay. Other considerations. So we really wanted to do a holistic and programmatic approach with, well, we obviously have to narrow that scope for the final design. Moonlight Brook is something we would have loved to focus more on, but just the scope of the project was the living shoreline. So we definitely wanted to bring in culverts and daylighting of the Moonlight Brook, as well as separate the Piscataqua River reach upstream, and then also reduce pollutants entering Moonlight Brook from non-point sources. So that's definitely something we recommend for the park, Schanda Park, but this wasn't realistic for our focus right now. But the Moonlight Brook is a really big feature of the park and definitely like a lot to it, and there's a lot involved in repairing it, but it's definitely something that should be worked on in the future. Okay.
Hi, I'm Jess. Our next steps are pretty similar to other projects. We recommend continuing stakeholder outreach. There's the Lamprey River Advisory Committee. There's also the Riverfront Advisory Committee in Newmarket, and the typical stakeholders like abutters and residents. And so continuing outreach, seeking grant opportunities like the ARM Fund, and engaging in a consultant or several consultants for some more baseline data collection and to take the project through final design. Baseline surveys include title, elevation studies, getting a little more data longer term than what we were able to do in our initial baseline surveys. Getting some upland bathymetry data to determine existing grade and incorporate that into final design. And then the permitting pathway, pretty similar to other projects, engaging with a pre-application meeting early on, of course, with DES, potentially a standard dredging fill permit, dredging fill from the Army Corps, a shoreline permit by notification from DES, and also reaching out to an archaeological consultant, and at least for a site walk to determine if potentially a phase 1A needs to be done. And then we recommend, of course, maintenance and monitoring. Monitoring would obviously be part of the permitting. And then looking at success criteria in your plantings and analyzing percent cover each year and potentially replanting any plants that didn't make it. And then also preparing an invasive species management plan. There's quite a few invasive species in the park area. So addressing that and really cutting, pulling out plants invasive.
Question, Kyle?